Hello my friend, welcome back to You Can Do TV channel. Explore the exciting process of felling a large Grandis fir tree in Wales, using a Husqvarna 372 XP chainsaw with a 20-inch bar. Using the Husqvarna 372 XP, the logger begins the felling process, making precise cuts to control the tree's direction as it falls. The logger then prepares the cutting site, ensuring that the area around the tree is clear of obstacles and safe for operation. The powerful chainsaw ensures a smooth and efficient cut, allowing for a clean felling. Once the tree starts to lean, careful adjustments are made to guide it safely to the ground. The felling process requires significant skill, with the logger carefully monitoring the tree's movement throughout. The Grandis Fir, once felled, is then prepared for transport and further processing. The entire operation demonstrates the importance of safety, precision, and proper technique when handling large timber. By using the right equipment, like the Husqvarna 372 XP, the entire felling process becomes quicker and more efficient, ensuring minimal waste and maximum productivity. The final step involves removing any remaining branches, preparing the logs for their next phase in the milling or timber processing chain. This efficient process ensures that large trees are felled with minimal environmental impact, keeping the operation sustainable and effective. The logger's expertise and the chainsaw's precision make this process a key part of responsible forest management. The Usewood Forestmaster Turbo has transformed small-scale forestry work by becoming more powerful and efficient than ever before. Powered by the robust Kubota D1505 turbo diesel engine, this machine delivers reliable and consistent performance, even in the most demanding forestry environments. The hydraulic system is driven by a Bosch Rexroth 130L variable displacement pump, which provides precise control and significantly increased hydraulic power. It is built to handle demanding forestry tasks such as logging, wood processing, and transport from the forest to staging areas. The powerful hydraulic system allows for the use of a variety of attachments, including grippers, head guards, spreaders, and conveyors, allowing the operator to efficiently process wood in the field. Compared to its predecessor, the Forestmaster Turbo offers double the power and 20% more hydraulic oil flow, which greatly enhances the operational capacity and speed of all forestry attachments. This means that cutters, splitters, conveyors, and other tools work more smoothly and efficiently, resulting in faster processing of logs and timber. The machine's design focuses on durability and user comfort, featuring ergonomic controls to reduce operator fatigue during extended work hours. Despite its powerful engine and hydraulic system, the Forestmaster Turbo maintains excellent maneuverability, allowing operators to navigate tight and dense forest areas with ease. This is especially important in small-scale forestry where space can be limited. Additionally, the turbocharged Kubota engine improves fuel efficiency, and lowers emissions, meeting modern environmental standards. The Usewood Combi Master paired with its trailer is a versatile machine designed for efficient firewood processing. It combines cutting and splitting functions into one compact unit, allowing for quick and safe handling of logs. The Combi Master features a powerful hydraulic system that cuts logs up to a large diameter. While the integrated splitter divides the wood into uniform billets for easy stacking and drying. The attached trailer facilitates easy transportation and on-site operation, making it ideal for both professional use and private firewood production. Controls are user-friendly, enabling precise adjustment of cutting length and splitting force. The robust construction ensures durability under heavy-duty conditions, while safety features protect the operator during operation. This combination significantly reduces manual labor and processing time, increasing overall productivity in firewood preparation. The Usewood Combi Master and trailer system is highly valued for its efficiency, reliability, and mobility in wood processing tasks. Holtz Transporte Anton Schrenk specializes in timber transport through narrow terrains and rugged mountain passes. Using the powerful Mercedes-Benz Actros 2658 equipped with a dual multifunctional body, the company efficiently navigates challenging forestry roads. This specialized setup allows for precise handling of heavy logs even in steep or confined areas, making it ideal for alpine logging operations. The Actros 2658 provides high torque and advanced traction systems. Anton Schrenk ensures safe and reliable delivery of timber from remote forest sites to sawmills, demonstrating expertise in complex terrain logistics. Using a specialized unloading stick, the fully loaded truck of Japanese cedar logs is rapidly emptied in one swift motion. This traditional technique relies on precision and timing rather than machinery. With a simple pull or flick, the entire stack of logs cascades off the truck bed onto the ground in a controlled release. It's a display of practiced skill and efficiency, an unloading method passed down through generations. The whole process takes only a moment, showcasing the speed and effectiveness of this old-school forestry method. Darby Logger Days was a vibrant celebration of Montana's rich logging heritage, held in the small town of Darby. This annual event gathered loggers, families, and enthusiasts to honor the skills, traditions, and competitive spirit of the timber industry. The 2013 edition featured thrilling competitions such as axe throwing, log rolling, chainsaw carving, and crosscut saw races, showcasing the strength and precision of modern-day lumberjacks and lumberjills. Crowds gathered to watch professionals and amateurs alike battle it out in friendly contests while enjoying live music, local food, and craft vendors. The event also served as a tribute to the hardworking loggers who played a vital role in shaping the region's economy and culture. Darby Logger Days fostered a strong sense of community and pride, offering both education and entertainment for all ages. It was a dynamic mix of tradition, sport, and small-town festivity. Unloading a timber truck using a crane and cables is a common and efficient method in modern forestry logistics. This technique is especially useful at sawmills, wood terminals, or forest depots, where space allows for crane operation and precise control is required. The process typically begins with positioning the timber truck on a stable unloading platform. A stationary or mobile hydraulic crane, often equipped with a grapple and winch, is used to handle the timber. The crane operator first secures the steel cable or grapple around the bundle or stack of logs on the truck's trailer. Depending on the configuration, the logs may be lifted individually or in groups. The crane gently lifts the logs vertically to clear the bolsters, then swings them over to a designated drop zone or log deck. In some setups, wire ropes are used in conjunction with mechanical chokers for improved grip and balance during the lift. This method provides a high level of control, reducing the risk of damage to the wood and increasing operator safety. It is significantly faster and less labor-intensive than manual unloading or winch-based systems. Advanced cranes can handle large volumes of logs per hour, making them ideal for high-throughput operations. However, regular maintenance of cables, pulleys, and hydraulic components is essential to ensure continuous performance and safety. Crane and cable unloading remains a staple in timber handling, combining strength, precision, and efficiency. It is particularly valuable in rugged terrain or during winter operations when manual unloading becomes dangerous or impractical. Deep in the forest, heavy birch logs await their transformation, and at the center of this process is a massive 48-inch steel chainsaw. Designed to handle oversized timber, this saw delivers raw power and stability, capable of cutting through trunks over 1 meter in diameter. Before the first cut is made, operators assess each log's structure, looking for signs of twist, taper, or knots that could affect the cut. Once stabilized, the sawyer aligns the bar along the grain, ensuring the first rip will be as straight as possible. The long bar allows a full-length pass through thick wood, reducing the need. Out in the yard, one machine handles 2 tough jobs, lifting and splitting logs, with raw, old-school power. This is the Fordson Major tractor, fitted with a hydraulic high-ab crane at the rear and a spiral log splitter mounted on the side. The high-ab, despite its compact design, can lift substantial weight. Operators use it to move hefty logs into position for splitting. However, when lifting heavier loads, the tractor's front can sometimes lift off the ground, even with a solid anvil counterweight mounted up front. Its strength makes it a practical solution for remote operations where heavy-duty tools must do more than one job. Once logs are in place, attention turns to the spiral splitter. This tool drives logs onto a rotating cone that tears the wood apart along its grain. The motion is aggressive, and the tool's power is unforgiving. When not handled correctly, it can grab and spin logs violently, posing serious safety risks to the user. The process relies on coordination between the crane and splitter, with the operator adjusting each log's position and applying pressure gradually. Though rough around the edges, this setup is highly effective for breaking down large timber into usable firewood, especially in rural or off-grid settings where simple, durable equipment matters most. In this video, look at the process of felling a large tree in the Smolensk region, showcasing precision and care in timber harvesting. The process begins with assessing the tree's condition and preparing the area for safe operation. After determining the felling direction, the tree is carefully measured to ensure a smooth cut. . The chainsaw used, with blades measuring 1.6 millimeters, is precise enough to handle the thickness of the tree, which has a base diameter of 46 centimeters. Once the felling area is clear and the direction is set, the first cut is made at the base, followed by the notch cut to guide the tree's fall. The chainsaw ensures that the tree is felled with minimal resistance, controlling its direction. After the tree hits the ground, the remaining branches are removed, preparing the logs for further processing. The skilled logger ensures the entire operation is efficient and safe. This process is a prime example of proper logging techniques that maximize efficiency while minimizing waste. Behind every sturdy wooden cable drum lies a detailed production process rooted in craftsmanship and industrial precision. It all starts at the timber yard, where selected logs are chosen not just for appearance, but for their density, moisture content, and load-bearing capacity. These logs are then transported to the manufacturing line, where debarking machines strip away the outer bark, preparing the logs for precise shaping. Each log is examined for internal flaws using visual inspection or scanning equipment to avoid structural issues later in production. After debarking, the logs are sawn into boards of various thicknesses, depending on the intended component. Wide planks are typically reserved for flanges, while narrower cuts are designated for the barrel section. These boards are then planed to a uniform thickness, creating clean, workable surfaces for machining. Consistency in sizing is critical to ensure balance and durability in the final product. Flange production involves cutting the boards into wedge-like segments. These segments are arranged into circular forms and compressed using hydraulic presses to achieve perfect roundness. Once shaped, they are bonded with industrial adhesives and further reinforced using nails or wooden dowels. The flange edges may be trimmed to refine symmetry and sanded to remove roughness. Simultaneously, the barrel components, called staves, are milled and beveled to interlock neatly between the flanges. Each stave is machined to precise width and angle, ensuring a seamless connection. Specialized jigs help guide positioning and maintain spacing accuracy during fitting. The overall symmetry of the drum relies heavily on the alignment of these staves. With both flanges and barrel parts ready, drilling units bore central holes into the flanges to accommodate cable spindles. Grooves or cutouts may be added based on specific cable requirements. In some cases, ventilation slots or notches are machined into the flanges to meet customer specifications, particularly for high-voltage cable drums. Assembly begins by aligning the flanges and fitting the staves in between. Bolts, screws, and pneumatic nailers are used to fasten components together securely. The entire structure is clamped during this phase to hold its shape while fasteners are applied. In drums designed for heavier loads, internal steel rings or reinforcements may be added before the final seal. Next comes finishing. The exterior of each drum is sanded to remove splinters and enhance its appearance. Depending on usage environment, drums may be coated with protective layers, such as antifungal solutions or weather-resistant varnishes, to extend longevity. Before shipment, every drum undergoes a final round of inspection. Workers check for structural soundness, surface finish, and dimensional accuracy. Some facilities mark each drum with a serial number or barcode for traceability. Drums destined for export may also be heat-treated or stamped to meet international shipping standards. Finally, the drums are carefully stacked, loaded using forklifts or overhead cranes, and dispatched to serve in industries like power transmission, telecommunications, and infrastructure development, where dependable performance is critical. Crafted with precision, OSCA machinists' hammers and hand tools are designed for performance and durability, meeting the needs of professional users. The production process begins with the creation of the hammer's core using high-quality aluminum alloy 6082 T6P. This alloy ensures excellent mechanical performance, making each tool strong and reliable for heavy-duty tasks. The hammerhead is forged from electro-inductive hardened steel C45, giving it strength and longevity. The head is smoothed and polished for smooth striking faces, and the edges are blunted to ensure safety during use. The mechanical fixing of the hammerhead to the handle is secured with a steel wedge and red epoxy resin, ensuring a firm, vibration-free connection. The hammer's patented three-component handle is one of the key features that sets it apart. It consists of a nylon core for ultra-resistance, an anti-slip rubber grip for a secure hold, and a thermoplastic rubber protection layer for added safety. This ergonomic design provides comfort during use, even for long hours, while also withstanding oils and solvents typically found in work environments. Once assembled, the hammers undergo thorough testing to ensure their performance, safety, and quality. The finished products are then ready for use in a variety of professional applications, offering high reliability and precision. Each hammer is individually checked for defects, ensuring that only the best products reach the market. The final step involves packaging, where each tool is securely wrapped to prevent damage during transport. Hammers and hand tools are then distributed to various markets, providing users with the quality and reliability they demand. The entire process combines the latest technology with traditional craftsmanship, delivering tools that professionals can trust. Before packaging, all tools undergo a final quality control check to ensure they meet strict standards. The hammerhead's secure attachment to the handle is verified under testing to ensure strength and durability. Each hammer's vibration-free performance is thoroughly assessed, ensuring that the finished product performs to the highest standards. Through rigorous attention to detail at every step, from raw material selection to final inspection, OSCA ensures that each tool is built to perform under the most demanding conditions. In Anji, Moso bamboo poles aged 4 to 6 years and averaging 90 millimeters in diameter are selected, then cut into 2,500 millimeters lengths, an essential first step in bamboo panel production. Discover how bamboo poles are transformed into slats with precision and efficiency. First, the poles are fed into a specialized machine where they pass through a metal splitter, equipped with star-shaped knives. As the poles move through, the splitter slices them into rough bamboo strips, which are then collected for further processing. Watch as the process of auto-matching bamboo strip colors comes to life. After the strips are carefully planned, advanced machines automatically select and match their colors. The process begins with sanding the bamboo to remove the green and yellow skin, ensuring a smooth surface. Next, the system efficiently pairs the bamboo slats for perfect color consistency. This automated process enhances speed and accuracy, improving overall production efficiency. Turning bamboo strips into strands begins after boiling or carbonizing. The softened strips are crushed into coarse, fibrous strands using mechanical pressure. To ensure consistent texture and durability, this crushing step is repeated 2 to 3 times. The resulting strands serve as the raw material for strand-woven bamboo boards. Once processed, the strands are bundled and prepared for the next stage. This method enhances both the structural integrity and appearance of the final product, making it ideal for flooring and panel applications. Horizontal grain bamboo boards are made by gluing strips edge to edge, showcasing distinct bamboo nodes. Workers arrange the glued strips precisely, then load them into the hot press. After pressing, the finished boards are removed, and new strips are continuously fed in, maintaining a steady production flow. In this process, thin bamboo strips are glued and hot-pressed to form solid panels. The strips are arranged vertically, resulting in a single-ply sheet with a subtle, uniform grain. This side-pressed bamboo plywood typically measures 20 millimeters thick. To create larger structural elements, like beams or thicker boards, multiple layers are bonded together using high-pressure hot pressing. An essential detail in this process is the adhesive. All glue used is formaldehyde-free, ensuring the final products meet E1 or even E0 emission standards for indoor air safety. This not only makes the material eco-friendly, but also suitable for interior applications. Every stage, from strip alignment to final pressing, is carefully controlled to guarantee consistency and performance. Watch how a modern sawmill transforms raw pine logs into thousands of fencing and pallet boards each month. Let's explore the intricate process behind this high-efficiency operation. The journey begins with an automatic log positioning system that aligns each log for optimal cutting. This system feeds logs into the LPRO 10-blade saw, equipped with 1.17/4 blades, processing an average of 8 30 centimeters diameter logs per minute. Each log is scanned for quality before entering the saw, ensuring that only the best material moves forward. Next, an automatic log centering mechanism ensures precise alignment before the logs enter the MPRO block mill with 1.1/4 blades. This stage features a new automatic removal system, enhancing both efficiency and safety. The logs are sliced into block shapes, which will then be processed into various sizes depending on the order. The blocks then move to the dogger feed system, which automatically positions them for further processing. Here, the SFH unit, with 6 MPR01-1/4 blade heads, delivers high-speed, precise cuts. A dual high-production sawdust cleaner maintains cleanliness and ensures smooth operation. The machine is designed to minimize downtime and maximize cutting output. Edge trimmings are processed in a recovery line equipped with high-speed edgers. The mill's edger, featuring an automatic output system and SFH unit with 3 MPRO heads, ensures efficient trimming. This stage is crucial for creating uniform, high-quality boards. Waste materials are transported via conveyor belts to a mill 220 by 600 chipper, powered by a 100 HP motor, which includes automatic feed control to produce chips with excellent granulometric standards. Subsequently, the boards are organized by a high-production automatic grader capable of sorting up to 48,000 boards per shift using hydraulic cylinder actuation. This grading system automatically sorts boards by thickness and length, ensuring each piece is ready for its intended purpose. An automatic pack removal system then prepares the graded boards for the next phase. After this, the final boards are packaged and prepared for shipment, with precision labeling to ensure smooth delivery to customers. The entire system operates seamlessly, minimizing human intervention and maximizing throughput. This ensures that each product meets the highest standards of quality. Throughout the entire process, sensors monitor each stage, ensuring that quality is maintained from start to finish. The final output includes boards ready for packing and shipping to customers. The facility has been designed for maximum automation, allowing it to operate at peak efficiency with minimal human intervention. This comprehensive process enables the facility to produce up to 3,000 cubic meters of pine fencing and pallet boards monthly, showcasing the synergy of automation and precision in modern sawmilling. With streamlined operations and advanced machinery, this sawmill exemplifies the future of high-capacity, low-waste timber production. CNC machining in timber construction involves loading raw components, programming milling sequences, and monitoring each cut. Operators measure and finish parts manually, ensuring every element fits structural requirements for complex national and international wooden architecture. Bloomer Layman's new production facility in Grossenlüter specializes in modular timber construction, focusing on high-efficiency prefabrication. The process begins with careful architectural planning, followed by precision manufacturing of timber modules. Skilled workers handle the fabrication of each module, ensuring that each element is crafted to meet specific project requirements. These prefabricated modules are then transported to the construction site, where they are assembled quickly and efficiently. With minimal on-site work, the building process is streamlined, allowing for fast construction and reduced labor costs. The use of locally sourced renewable timber ensures sustainability throughout the entire process. The modular approach not only shortens construction times but also reduces the environmental impact, making it a forward-thinking solution for modern construction. Through this method, the company can also achieve high-quality, customized designs that fit the unique needs of each project. This efficient system allows for both smaller-scale and large-scale projects to be completed within a short time frame. Additionally, it provides flexibility for future expansions or modifications to the building structure. Inside Stockholm's National Museum of Science and Technology, the Wisdom Dome showcases advanced free-form timber construction. Each curved glue-limb element was milled on CNC machines, shaped precisely to fit the complex geometry. Assembly required exact sequencing, each beam numbered and pre-tested before site delivery. On location, the structure was mounted using cranes and adjustable supports, allowing gradual closure of the dome. The wood construction not only supports architectural expression, but also meets high structural demands, merging digital design with hands-on craftsmanship in one of Scandinavia's most innovative timber builds. Every detail of this project reflects the collaboration of modern technology and traditional craftsmanship. The Magician's Hat project in Rapperswil represents a groundbreaking example of modern timber construction. The challenge was to create a multifunctional structure for both the Nies Kinderzoo and corporate events, all while ensuring environmental sustainability. After thorough planning, the decision was made to use prefabricated timber components, offering both scheduling benefits and eco-friendly advantages. With 3D modeling and parametric design, the building's geometry was defined and optimized for both production and assembly. Each component was simulated in advance, ensuring precision and avoiding potential errors in the manufacturing process. The timber elements, including large roof sections weighing up to 4 tons, were thoroughly produced and tested for accuracy. The final test came with the iconic hat-shaped roof, a 20-ton structure that required exceptional precision to fit perfectly into place. On-site assembly presented its own set of challenges. Safety and precision were key, with every timber piece needing to slot together with millimeter-perfect accuracy. The structure was erected within tight time constraints, highlighting the importance of expert teamwork and careful coordination. As each timber element arrived at the site on schedule, large cranes were used to lift the heavier pieces into place. The roof structure, in particular, required thorough handling due to its size and weight. The 470 timber elements that formed the roof had to fit together with absolute precision, putting additional pressure on the project team to meet their exacting standards. The project also incorporated advanced sustainable building practices, including the use of wood sourced from certified forests, further underscoring its commitment to environmental responsibility. Despite the challenges of scale, time, and weather, the project demonstrated how advanced planning, careful fabrication, and expert assembly can result in a remarkable and sustainable architectural achievement. The Magician's Hat serves as a testament to the capabilities of modern timber construction, offering a striking example of what can be achieved when quality, sustainability, and precision come together. Welcome to the installation guide for the Alpha Sauna Outdoor Square Sauna. This video walks you through the complete assembly process, ensuring everything is set up correctly for optimal use and longevity. Whether you're a first-time installer or an experienced builder, the process is straightforward and requires only basic tools. Make sure to review all parts and hardware before beginning to ensure nothing is missing. Begin by laying the base frame and checking that it's level. A properly leveled base ensures structural stability and prevents future misalignment. Use a straight board to align the base structure accurately. It's recommended to check the diagonals for squareness before moving to the next step. Measure and mark the middle point to position the fixed center plate, which includes a drainage hole. This drainage hole prevents water accumulation during cleaning or after use. Make sure this plate extends 10 centimeters outward, then fix it with screws, ensuring the alignment remains consistent throughout. Next, install the middle floorboards. Lay the planks with equal spacing and a 10 centimeters overhang. If using natural wood, ensure the grain direction is consistent to improve aesthetics and performance. As you fit them together, keep the joints tight. A rubber mallet can help close small gaps between planks without damaging the surface. Secure the outer panel with screws, and make sure the edge plate aligns evenly. Pay attention to spacing to allow for expansion and contraction due to humidity. Adjust the central plank to match the groove spacing for a uniform finish. The entire floor should feel solid when you walk across it, with no bounce or movement. Before proceeding, step across the floor to check for loose planks or creaking sounds. Now move on to the rear and front door panels. These panels are pre-fitted with positioning pins to make the setup easier. Align the pins with the pre-cut slots on the base to ensure stability. Identify the center of the back wall and tap the panel into place so that it slides into the card slot. A level tool is useful here to ensure vertical alignment. Once aligned, support the panel from behind. Repeat this for the front door panel, aligning it to the center. Use a wood block to secure the two front panels tightly together. Check that the door frame is square and adjust if needed before securing it completely. If you're working alone, consider using temporary clamps to hold the panels while aligning. Continue by installing the upper boards of the sauna room. Each board should be tapped gently into place and fixed with a steel belt. Keep the tapping consistent to avoid creating uneven surfaces. Half-nail each board so it's secure but still adjustable if needed. This technique helps if later boards require slight repositioning. Install the sides symmetrically, and check that the height remains consistent, with an allowed error margin of under 5 centimeters. Use a measuring tape to verify height after every few boards. In corner sections, use smaller panels if necessary, and for flat sections, use longer continuous boards. The last board should be carefully adjusted to maintain the sauna shape. Apply steady pressure when inserting the final board to lock the structure. Avoid using forceful tools near the edges, as it may damage the tongue and groove connections. Now it's time to install the steel bands. These can be tightened or loosened as needed. Gradual tightening from both ends helps maintain symmetry. Tap them lightly to adjust their position. Each band has 4 screw holes and is adjustable in length. Avoid over-tightening to prevent warping the outer wall. The exhaust vent, which will later connect to the chimney, is positioned in the center of the rear panel. Ensure the vent opening is unobstructed. When attaching the steel bands, place the front band behind its fixing screw and the back band in front of its respective screw. Make sure all bands are evenly spaced along the height of the sauna. A spirit level can help confirm that bands are parallel to the floor. With the steel belts in place, the structure of the sauna is now complete. Take a moment to visually inspect the entire frame for alignment and tightness. The chimney must still be installed on the roof, which allows for proper smoke ventilation when using a wood-burning stove. Check that the chimney pipe matches the flange opening for a secure connection. Finally, install the sauna stool and footboard. These come with pre-drilled holes, so align them with the base and fix them securely. Use a level to ensure the seating surface is flat and comfortable. The footboard enhances user comfort during sessions and adds to the overall finish. Make sure all seating components are firmly fixed to avoid shifting during use. Once all parts are in place, your Alpha Sauna outdoor square sauna is ready for use. This revolutionary timber handling vehicle features a 300 degrees rotatable cabin, providing the operator full visibility during loading operations. With its hydraulic shifting system, logs can be aligned and stacked precisely. The driver and crane operator share a protected cabin for better coordination. Functions of the trailer are controlled directly via crane joystick, speeding up the loading process. Designed to collect multiple log piles efficiently, the unit also enables loading of non-crane vehicles. Its crane control is low maintenance and reliable, and operators can access the crane quickly and safely. This system marks a major innovation in round timber logistics. The Dahl Ratio Plus steering system is an innovative solution designed to revolutionize the way heavy-duty vehicles handle. This intelligent steering system combines the advantages of self-steering with the precision of forced steering. The system integrates a hydraulic lock and a hydraulic clamping device for secure cargo handling. One of its key features is the track-and-track mode, which enhances driving stability and safety, making it easier to navigate through tight spaces. Unlike traditional systems, the Dahl Ratio Plus eliminates the need for manual steering adjustments while reversing, improving efficiency and ease of operation. With a focus on durability and low maintenance, this system ensures long-term reliability for demanding operations. The integration of these advanced technologies makes the steering system an ideal choice for those seeking enhanced control, safety, and performance. Its user-friendly interface allows for smooth operation, while the seamless integration with existing vehicle systems offers greater convenience. The journey of MDF production begins in a forest farm where pine trees are carefully cultivated. After seeds are selected, they are planted in special tubes and nurtured in a controlled environment. Around 7 months later, the saplings grow strong enough to be planted in the field. Over the next 17 years, the trees are carefully managed and harvested using mechanized equipment, significantly improving efficiency. Once harvested, the pine logs are transported to the factory, where the first step in production involves stripping the bark from the logs using a peeling machine. The logs are then chipped into small pieces or wood shavings. These shavings go through a process of sorting to select the ideal size for MDF production. The discarded material is repurposed as biomass, providing energy to fuel the plant's operations. Next, the wood shavings are turned into fibers in a large digester, where they are combined with synthetic resin and dried with hot air. The fibers are then formed into a mattress-like structure using specialized equipment. This mattress is further processed, including scanning to ensure even density throughout. Following this, the MDF panels are pressed under high heat and pressure, ensuring that the materials bond into a cohesive sheet. After cooling, the panels undergo additional steps like sanding and cutting. The final product is available in both natural and pre-finished options, ready for use in a variety of applications such as furniture, construction, and packaging. The entire process is automated, ensuring precision and consistency, with technology playing a crucial role in achieving the high-quality results that MDF is known for. This automation eliminates the need for manual labor in many stages, streamlining the production and enhancing efficiency. Additionally, the factory applies sustainable practices by using the biomass from wood waste to generate energy, making the production process more eco-friendly. The MDF panels produced are not only durable but also versatile, offering an ideal solution for a wide range of industrial applications. Watch the Taiga DP 1-disc sawmill in action as it efficiently cuts logs with a circular saw. Designed for logs up to 90 centimeters in diameter, this sawmill provides high precision and productivity. The cutting process is quick and effective, ensuring smooth and accurate cuts every time. The sawmill uses advanced technology to maintain a steady feed rate, minimizing downtime during operation. Once the logs are securely positioned, the circular saw slices through with minimal resistance, resulting in clean cuts. This machine is an ideal solution for both small and large-scale timber processing. With a reliable design, it operates continuously, reducing labor costs and increasing output. In the town of Village, a birch log is set for processing using a high-speed, double-action saw. With 200 double strokes and a feed rate of 12 millimeters per stroke, the machine begins its work, cutting each log with rhythmic precision. The raw birch is firmly positioned to ensure cleaner slices, but the operator must constantly adjust settings to prevent uneven cuts. Despite mechanization, human input remains critical. Misalignment or inconsistent feed rates can cause variation in board thickness, seen clearly when switching between finer and coarser feed modes. Measurements are taken throughout the cut to monitor dimensional accuracy, ranging from 19.2 millimeters to over 20 millimeters, depending on feed pressure and blade contact. Occasional imperfections like knots or dense fibers add complexity to the process, demanding further manual calibration. Though automation supports consistency, real-time observation and adjustment remain essential. This setup reflects the balance between machinery and skilled handling in modern timber processing. Discover the Heli Scrag Mill in action, featuring advanced scanning and cutting technology for efficient timber processing. The production process begins with logs being fed into the system, where the in-feed scanning mechanism accurately measures the log diameter. This data is then used to position the cradle and saws with a simple touch, ensuring precise cuts every time. The upgraded Scrag Mill is equipped with 3 saw vertical edgers, providing high-quality, smooth edges for the cants. Once the logs are processed, the movable 2-strand transfer chain enables the cants to be sent out either side or through the end, offering flexibility in the milling process. This feature enhances productivity by allowing efficient movement of materials through the mill. The combination of scanning technology and vertical edgers ensures accurate cuts, improving the quality of the final product. After the logs are positioned and scanned, the mill automatically adjusts to ensure optimal cutting angles. The entire process is streamlined, reducing manual intervention and improving processing speed. The vertical edgers work in tandem with the scanning system to trim the cants into perfectly straight and smooth surfaces, ready for further use. This integrated system allows for continuous, uninterrupted production, resulting in a more cost-effective operation. The Heli Scrag Mill is designed to handle large volumes of logs with ease, and the automated scanning system reduces the need for manual adjustments, increasing operational efficiency. The system is also user-friendly, allowing operators to make quick adjustments for different log sizes and milling requirements. The seamless integration of these advanced features makes this mill ideal for both high-volume and custom timber processing, ensuring consistency and high-quality results throughout the operation. Additionally, its compact design allows for space-saving installation in a variety of mill layouts. Take a close look at how raw logs are transformed into high-quality lumber through an efficient sawmilling process. The journey begins as the logs enter the in-feed system, where they undergo species analysis and are cut to the correct length. Once sorted, the logs move on to the debarker to remove the outer bark. From here, the logs are sent to the hew saw, a machine designed to cut them into rough lumber with incredible precision. The lumber is carefully sorted by species, length, and dimension to guarantee consistency. The mill efficiently collects bark, chips, and sawdust, ensuring there is zero waste produced during the process. The next step involves placing the rough lumber into a dry kiln where moisture is removed, making the wood stable and ready for further processing. Once dried, the lumber moves to the planer, where it is smoothed to achieve a refined finish. At this stage, quality checks are performed to ensure that every board meets the highest standards. The lumber is then carefully stacked, ready to undergo a final inspection before packaging. Finally, the lumber is trimmed to maximize value and quality before being stacked and securely banded for delivery. This entire process at the Colville Mill demonstrates the seamless integration of advanced technology and skilled craftsmanship, ensuring a top-tier product.